little rule for today, also supposed to be revision, raising something to a power. So the rule is then that this is a to the power m times n, which obviously we can also write like that. Okay, so please notice the difference between these two things over here, that one and that one. Here, you've only got one base, and this means 3 squared times by 3 squared times by 3 squared. So if you're going to, because it's cubed, right? So if you're going to use the other rule that we used, that's 3 to the 6. If we're going to multiply them like this rule says, then that's 3 to the 6. So everything's working and it's fine. So this is the time when you multiply when they're not written like this, right? Notice how different it is from that. Now we've got 2 lots of 3's, and this is 3 to the power 5. Okay, so please don't muddle those up. Our usual rule when we're doing this, you picture the two 3's here, you picture the 3 of them over here. Of course, there's 5. For this one, it's the same thing as this thing multiplied by itself 3 times, and that's why you times. So this one over here, if you're raising something to the power 3, of course you can go and write it out like this, right? You can do this. This is called really wasting your time. But of course, that is what it means. So you can do that if it makes you happy. And if it's raised to the power 100, you're going to be busy for a very long time. But you can do that. Of course, it's equal to that. But what you can do is you can also use the rule. So the rule says you can multiply. This thing has its own exponent. It's 1. The square belongs only to the a. This thing has its own exponent. It's 1. And this one has its own exponent. It's 6. So if we're going to multiply, this is 5 cubed, then a to the 6, b to the 9, c cubed. At the bottom, 6 to the 3, d to the 12, right? Massive, massive things. And then you might want to work out these numbers and say 125 at the top. And at the bottom, we've got 6 cubed, which is 216, and you're done, right? So the rule works the same as usual for everything, both in the denominator and the numerator. Last one, so something like this. In fact, I'm going to change this exponent to 4, just so that it's clear that you know how it goes for everything. So then this is saying that there are going to be 4 negative signs. So that is positive, right? This one, I think you'd be better off before you did anything else. In fact, I'm going to leave that for now. I think before you do anything else with something like this, you'd be better off simplifying first. So I'm going to say a negative divided by a positive is a negative. 6 goes into 12 twice. These 2 a's cancel with 2 of those. This is a squared. This b cancels with 1 of those. There's a b left, and there's 2 c's at the top. So that's going to be a lot easier to work with. But if you didn't, if you used the 4 first, it wouldn't matter. It would be fine. Either one is fine. So you can cancel in the bracket, or you can raise it to the power first. It won't matter. Okay, so now I'm going to use that. So that 4 is saying that we have got 4 negative signs. So that's positive. Now that's c to the 8, 2 to the 4, a to the 8, b to the 4, right? Times by negative 4 a squared bc to the 4, which I'm hoping you can see is the same thing as saying negative 4 at the top. Then I've got a squared at the top, b at the top, these 4 c's, and these 8, so that's c to the 12, right? And at the bottom, I've got 2 to the 4, which is 16, a to the 8, b to the 4. You are never, ever allowed to have the same base twice in your answer. So if I have b here and I have b here, it's unsimplified. If I have a here and I have a here, it's unsimplified. Plus no unsimplified numbers. So to finish this thing off, I've got negative. I've got a quarter. You don't need the 1. I've got 6 a's left at the bottom, 3 b's left at the bottom, and 12 c's at the top. Okay. I am hoping this is okay. Let me just show you these 2 as well. This is just to prove to the point. This is saying that every single time we're going to multiply, so that we're going to say 3 to the power x plus 1 times by 2x, which is the same as saying 3 to the power 2x times by x plus 1. So no matter how weird it is, we multiply those things. So this would be 3 to the power 2x squared plus 2x. So we multiply in this situation. If we had something like this, this would be 3 to the power x plus 1 times by 2x minus 1. Distributive law, well, not distributive law, but FOIL. So that's 2x squared minus 2x, minus x, sorry. Let me go back and change it. So that's minus x, then plus 2x, and lastly, minus 1. And you would, of course, collect like terms as usual. So the idea is supposed to be that you understand that these rules always work in every single situation, always. The stuff you're going to have to do for homework today should be quite easy, not terribly scary. Don't worry about all this stuff. We'll apply it later on.